I'm here to introduce to you Halo, our new flexible film coating, and to give you a bit of an insight as to the development process behind the scenes. Due to its more porous nature, the chemical bond required for a film and vinyl type coating is completely different to that of a paint type. So the chemistry behind Halo is completely different and completely different to anything we have currently in the Gtechniq range. Hydrophobic performance, ease of maintenance, chemical resistance, in addition to proven UV resistance and also ease of application, which is very important. One of the more advanced benefits of using Halo is resultant surface slickness and anti-adhesion properties. Now, typically film and vinyl have very grabby textures, so when using Halo, it completely transforms surface energy to produce a very slick finish, very similar to that of paint. However, Halo remains flexible once cured, which means it doesn't interfere with any self-healing properties of modern paint protection film. So from an aesthetic point of view also, Halo increases the colour depth and richness on gloss type film while not affecting satin or matte finishes. So initially, to take a conceptual idea from paper into a physical product, you have to go through and pick out the key performance points of a product. To do that, we used our in-house and external knowledge to put together 4 different prototypes to go forward. Each will be tested alongside each other to find the leading prototype that will be pushed forward into a final product. We have to look into application. We have to make sure the product isn't too thick or too thin, so it's nice enough to control. Next up is working area. How long and how far can you spread this product without creating problems? Now, a vinyl and film type coating will need longer to absorb into the pores of the film, so it needs a longer and more stable curing time and working time than a typical paint type coating. We have formulated Halo in such a way that you can remove high spots or missed sections from a panel up to 24 hours after application to make it very safe for use. That is removal with our MF1 microfiber cloth. So anywhere up to 24 hours, if you've missed a section, just over wipe. And we have tested this with our hydrophobic and chemical resistance tests to make sure there's no issues with performance if left for that period of time. We made sure we tested it on as many different manufacturers and types of film as we could to ensure compatibility. Now, we have had samples sent in from leading manufacturers such as Suntech, Lumar, 3M and Avery Dennison, as well as smaller and independent manufacturers to make sure we have as broad a spectrum as is physically possible. Once we understood how the prototypes behaved, it was time to investigate how they performed. Now, to understand how Halo will perform over years of exposure to natural elements and wash chemicals, we have to use 2 key machines. The first is a digital surface tensiometer, a device used to measure the contact and roll-off angle of water droplets. From here, we can measure the hydrophobicity of both uncoated and coated film to find the increase, or what we refer to as the delta. Each type of film will have a different starting hydrophobicity, so the delta will be different for every different type of film. During testing, we found Halo to produce up to 110-degree water contact angle in certain combinations, which is exceptionally high. Halo has the ability to turn any film type from hydrophilic, water-loving, to hydrophobic, water-hating, providing the water beading phenomenon that everyone enjoys. The second piece of equipment used is an abrasion machine. This will simulate contact washes. Now, for this, we used a generic car sponge, Scratch Heaven, a neat W2 all-purpose cleaner, which is heavily caustic and measures 12 on the pH scale. This meant the prototypes were subjected to extremely aggressive chemical degradation. Coating longevity is tested by using both the tensiometer and abrasion machine. Water droplet measurement is taken every 500 scrub cycles to understand and map out drop-off of the prototypes. With a typical test requiring 5,000 cycles, we ran Halo through to 10,000 to try and find the point of failure, to no avail. Another common demand for a PPF and vinyl specific coating is UV resistance. In our laboratory we have a QUV accelerated weathering machine. This utilises very specific UV wavelengths to produce and accelerate the effects of natural sunlight. Modern paint protection has come a long way in terms of UV resistance, so we had to ensure Halo does the same. This is a very serious claim we have to live up to, so we chose to subject our prototypes to ISO testing. And what better way to show that our product performs than performing testing in accordance with ISO 4892-2, which is the most aggressive form of UV test of its kind to ensure Halo does not induce yellowing or embrittlement of PPF and vinyl. Now, the final piece of the puzzle is real-world testing. This is arguably the most reliable way to collect data. No matter your capability for accelerated weathering, there is nothing quite like real-world driving, real roads, real weather, to really find out how good a product really is. Now, a number of staff cars here at Gtechniq HQ were coated with all 4 Halo prototypes, including a handful of cars from around the globe that were coated with our accredited Gtechniq network to really put Halo through as many different conditions as is possible. And after 6 months of driving, one prototype stood out head and shoulders above everything else, and that was in terms of dirt repellency, continued hydrophobic performance and ease of maintenance, which are amongst the key things we were looking for Halo.
Okay.
So a thorough but realistic test program has presented us with a unique and very high performing coating, one that we are very proud of. We hope you enjoy our smart surface science.